All right, let's jump right into today's explainer because we're unpacking a genuinely fascinating engineering design project. We are looking at the semi-automated scissor lift motorcycle loading system. It's this incredibly innovative academic prototype that tackles a highly specific but honestly very widely experienced mechanical challenge. But first, to really appreciate this work, we need to know who's behind it. This project is the culmination of the BDA 4084 Integrated Engineering Design course. It was developed by Group Terra, a team of 5 really dedicated student engineers: Mohammed Al-Noor Faiz, Najan Shami, Mohammed Hazwan, Mohammed Ashraf, and Mohammed Haraz Azri. And, a project of this caliber doesn't just happen in a vacuum. They were guided by their esteemed lecturers, Dr. Aslinda Benti Saleh and Prof. Majid TS, Dr. Ahmed Mubarak bin Taj Larafan.
So here is our roadmap for today. We're covering chapters 1 through 9 of their final reports. We'll start with the heavy lifting problem, move on to engineering the scissor lift, check out their prototyping and testing, look at the sustainability and business strategy, and wrap it all up with a project summary.
Okay, let's dive into this. Section 1, the heavy lifting problem. Picture this. You're trying to deadlift a machine that weighs anywhere from 150 to literally 300 kilograms. That is the typical weight of a heavy motorcycle. Now think about your standard 4x4 pickup truck. Great for mobile mechanics for sure, but they have ridiculously high ground clearance. So pushing that much dead weight from the ground, up a steep incline, and into that high truck bed, it's an absolute nightmare. It is physically exhausting, and honestly, it introduces a severe risk for musculoskeletal disorders and back injuries. And that's not even mentioning the risk of dropping and completely destroying the bike itself.
To really see the gap in the market here, let's look at the alternatives. Usually, people use these manual, narrow aluminum ramps, but you need 2 or 3 people to do that safely. So a solo mobile mechanic, they simply can't do it alone. Now, there are commercial powered loading systems out there, but they are incredibly expensive, they're super bulky, and they usually require you to permanently modify your truck. So this is exactly where Group Terra saw their opportunity. They envisioned a semi-automated scissor lift that's compact, affordable, and most importantly, lets a single user load a bike safely without altering their truck.
Which brings us to Section 2, engineering the scissor lift. After running through a bunch of brainstorming and design techniques, the team actually landed on the scissor lift mechanism as their core solution. Just as a quick refresher, this mechanism uses crossed arms connected with pivot joints. When you apply force, say with an actuator or a hydraulic jack, it gives you this highly stable, perfectly vertical motion. They pick this over things like electric winches or complex bed-mounted cranes because it honestly strikes the absolute perfect balance. It's structurally stable, it's affordable to build, and it guarantees the motorcycle stays perfectly level the whole way up. All right, let's look at the numbers because the engineering logic here is rock solid. They had to pinpoint their exact design load. So step 1, we start with that maximum motorcycle mass of 300 kilograms. Step 2, we calculate the weight, giving us 2943 newtons. Step 3 is crucial, applying a factor of safety of 2.0 to make sure nothing fails under pressure. Which brings us to Step 4, a final design load of 5,886 newtons. That exact number became the absolute baseline for all of their component calculations and stress simulations.
Let's see how they built it. Section 3, prototyping and testing.
Out in the workshop, the team took everything from the CAD screen and brought it into reality. Measuring, cutting, welding. You can see them working on the base frame here. They deliberately went with mild steel for the structure. Why? Well, it's got immense strength to easily handle that 5886 Newton design load. It's super easy to weld for really strong joints, and, crucially for a student prototype, it's highly economical. You can really see it taking shape from raw metal to a tough finished base. And here it is. This is the fully realized physical prototype, fully extended. Look at the completed scissor mechanism in those pivot joints. They even added caster wheels on the base for mobility, which is a really clever touch. By setting it up like this, they've practically solved the single-user loading problem. You just secure the bike on the top platform, and the semi-automated mechanism does all the heavy vertical lifting right up to the tailgate.
Now, something important to keep in mind. This is an active, ongoing academic project heading toward a major symposium. So the final verification is actually happening right now. The team is running full SolidWorks static simulations, checking von Mises, stress, displacement, all that good stuff, right alongside real-world physical full load tests. Those final numbers are just pending validation to make absolutely sure everything works flawlessly in the real world before they make any final commercial claims.
Moving right along to Section 4, Sustainability and Business Strategy.
Great engineering isn't just about making things work.
It's about making them actually matter. This design directly supports several sustainable development goals, specifically SDGs 3, 8, 9, and 12. For instance, it massively reduces workplace injuries, and the durable mild steel construction means it's built to last and easy to repair. From a business standpoint, the value proposition is just phenomenal. For workshops, mobile mechanics, or even motorsport teams, this gives you a safer loading experience, requires way less manpower, is way cheaper than a permanent hydraulic liftgate, and uses standard, easy-to-maintain parts. It's a total game changer.
And finally, Section 5, Project Summary and Conclusion.
This project absolutely hits the nail on the head when it comes to the safety and ergonomic bottlenecks of loading a motorcycle. Group Gentera Terrace took a huge problem and, through rigorous engineering, turned it into a highly practical, single-user solution. So I'll leave you with this thought. With the physical prototype built and those final CAD simulations wrapping up, how is this semi-automated scissor lift going to completely redefine standard transport for mobile mechanics everywhere? I, for one, absolutely cannot wait to see their final symposium results. Thanks for hanging out and exploring this with me today on The Explainer.